Hello again. In this lecture, we'll try to understand what are the requirements of programming model. Remember, we learnt what is distributed processing. Distributed processing, which is also called as a parallel processing, which is also called as taking the computations to the node. But do you think the distributed processing happens on its own? Is there a magic? For example, if I want to add the salary of all the employees, it was a one big table, I will say sum of all the rows. But my data is not at one place now. My data is in different systems. Considering that situation, if I have to add a salary of all the employees and get a final number which I want, how do I do that? Because the data is not at one place now. So what is that we need for a distributed processing? Any idea? You would need a programming model. Oh, what is programming model then? It's a very generic term. Can you think of what is programming model? Programming model is an abstraction over a machinery or infrastructure which has runtime libraries, which is coded in a high level programming language, and also it will have a low level programming language also. Because we will not be able to talk to the machinery. Computers talk in a language of a binary, 0 or 1. We would need an abstraction over a machinery which consists of a runtime library which is coded in high level or low level languages, or a combination of both. That is programming model. Now that we understood, we need a programming model for a distributed processing. And what is programming model? We understood that. We have already seen what is big data. What kind of a programming model is needed for a big data? Any thoughts? We need a programming model which has a programmability over distributed file systems or a distributed storage. Now that we understood we need a programming model has a programmability over distributed file systems, what are the requirements of the big data programming models? Any thoughts? I would say the programming model should support the big data operations, should be able to handle the fault tolerance. A big data programming model should allow us to add more racks, and also the big data programming model should be optimized for specific data types. We'll discuss them one by one. What kind of operations are there in big data? Any thoughts? Can you think of big data operations? When we say big data, what is it? It's a huge amount of data. Will we be able to store the huge amount of data in a one machine? No, not really, right? First and foremost thing is a programming model should support the big data operations. Some of the big data operations are you have a huge amount of data that need to be split into smaller chunks. So that is one of the aspect. The second aspect is it is not only about just splitting the data. It is even accessing the data faster, because the data is not one place now. The data is distributed across different systems by splitting that. And also when the data is in a different systems, we should be able to access that fast. And also it should allow us to distribute the computations to node, which we just discussed. That is a distributed processing. The programming model in a way should allow us to distribute the program to the node where the data exists or distributed. So these are the different big data operations. The next thing is the programming model should handle the fault tolerance. By the way, what is fault tolerance? Fault tolerance is the property that enables a system to continue operating properly even though there is a failure of some of its components. For example, if you have a big ecosystem, it may be big data ecosystem or it's a data ecosystem which will have multiple components, multiple systems, multiple nodes. So even though one of the node or one of the system comes down, in that case also quickly it should be able to recover and the whole system should not stop functioning. This is a fault tolerance. How do we achieve that by using a big data programming model? There are a couple of things like replicating the data partitions. Whenever you have partitioned the data, that should be replicated. And whenever some system crashes, it should allow us to recover the files whenever needed. So we'll see this in detail when we cover the HDFS. For now, the programming model should allow us to handle the fault tolerance. Adding more racks. When you say adding more racks, what are we talking here when you say rack? So what happens is in case of data centers, we have a particular racks. Within that racks will stack all our servers, all our the CPUs. So that is the reason we call it as a adding more racks. Assuming that in this context, you have set up a company or startup. As a part of your startup, you are receiving almost 1 TB of data and you have around 20 systems to store that data. What happens is, fortunately, you will get more orders and you have to process another 250 GB of data. So now the programming model is taking care of processing the data across the 20 machines. To process another 250 GB of data, we will add 5 more machines. Programming model is working fine when the 20 machines are there. The moment we add 5 more machines, it should not stop working. Or it should allow us to distribute the data for these 5 more machines and process the data for these 5 more machines also and get the results from these 5 more machines also and ensure the results are combined with the some of the results from 20 machines and it should be represented back or given back to the user. Big data programming model should allow us to add more racks. When I say add more racks, in this context, it should allow us to add more systems or more machines. That is one of the very important aspect of big data programming model. Next thing is, in the context of adding more racks, we'll try to understand vertical scaling. Assuming that you have a initial capacity of your server around 250 GB of the RAM and almost 500 TB of hard disk. Then because of your load, you end up requiring more capacity, almost 500 GB of RAM and almost 1000 TB of hard disk. In this case, there are two options. One of the option is you have one particular server, you go ahead and increase the capacity of that server from 250 GB RAM to 500 GB RAM, and also the same server go ahead and increase the capacity of that to 1000 TB. This whole thing is called as vertical scaling. One more example. Assuming that you have a laptop. Your laptop is of 16 GB RAM and 2 TB hard disk. What you can do is, in case of vertical scaling, you can go ahead and increase the capacity of your laptop by adding one more RAM of 16 GB in the same laptop and changing the hard disk from 2 TB to 4 TB. That is also called as a vertical scaling. Then what is the opposite of this? That is horizontal scaling. Assuming that we have a same requirement, 250 GB of RAM and 500 TB of hard disk, which is taken care by these 4 machines. Our required capacity is 1000 TB hard disk and 500 GB RAM. Obviously, we need 4 more systems. Either we can go ahead and increase the capacity of this individual system, which is also called as vertical scaling, or bring in 4 more additional system and connect them over a network. We are increasing the capacity of the overall system by adding 4 more systems. This is also called as horizontal scaling. when we want to increase the capacity of any system, if we increase the capacity within the same system, then it is called as a vertical scaling. If we increase the capacity by adding one more system as a part of the network, this is called as horizontal scaling. Horizontal scaling is also called as a scaling out, and vertical scaling is also called as scaling in. I hope you guys got what is horizontal scaling, what is vertical scaling. Now, one of the last important thing which need to be supported by a big data programming model is optimized for the specific data. Why is that we are saying optimized for a specific data? What do you mean by optimization here? When I say optimization, we are talking about more amount of data need to be processed in less amount of time. That is a kind of a optimization. What happens is, as a part of the big data, as you know, we don't have only one set of data. It may be structured data, it may be unstructured data, it may be semi-structured data. So it is very difficult for one programming model to have a super duper performance for all the types of the data. That is the reason what is very important is, if you have a table kind of a data, you need to have a programming model which is optimized for storing and processing of table kind of a data. If you have a document kind of a data, you need to have a different programming model which is well versed and also which is optimized for document type of data. That means if there is a document type of data, the programming model which is supporting this should be very efficient and process the data in a less amount of time. But we cannot have one programming model taking care of both the things. They may take care, but they may not be as optimized as one specific data. In the similar way, there should be a programming model if a graph data comes into picture. Remember, when we add friends in Facebook or professionals in LinkedIn, will have friends of friends. This may be a one of the network which is there here. We may end up having one more network like this. So this becomes a graph. A same programming model which is optimized for table will not be efficient working on a graph. We would need a different programming model which is optimized for storing and processing of the graphical data. In the similar way, we cannot have a programming model which takes care of the real-time data. In a stream of data which is coming continuously, that is called as a real-time data. So we may not have a one programming model which is optimized for all these kinds of data. We may have a different programming model which is optimized for stream data.